Okay, now see this question. On a thin rod of length L equal to 1 meter lying along the x-axis with one end at the origin x equal to 0, there is uniformly distributed charge per unit length lambda equal to kx, where k is constant and its value is this. Find the work done in displacing a charge q equal to 1000 microcoulomb from a point, this point to this point. Okay, so let's draw the rod first. So this is the rod. Okay, now because of this rod, first of all I need to find the charge, sorry, the potential at a distance y from its end. This is the origin. Okay, this is the origin. So first of all I need to take an element at distance x from the origin along the rod. So let's say this is my element of length dx. So the charge on the element dq will be what? Lambda dx. So lambda is going to be kx. So kx dx. Okay. Now due to this element, I want to find the potential of this point. Okay. So for that, I need to know this distance. This distance is r. R will be equal to root of x square plus y square. Okay. So the potential will be how much? So the potential dv will be dq by 4 pi epsilon naught r. Simple. Okay. Now we simplify this. So dv will be equal to dq is what? Kx dx by 4 pi epsilon naught. R is root of x square plus y square. Now in this formula, y is a constant. We are just changing x. Okay. Y will be constant. So this is constant, x is variable. So how do we find the total potential now? So for total potential, we need to integrate this. Okay. So we need to simplify this function first. So for that, let's say that root of x square plus y square is equal to, oh yeah, it is given to be r, correct? Then when you differentiate this, so dr will be what? 1 by 2 root x square plus y square. We are applying chain rule, right? And then derivative of this will give you 2x dx. 2x dx. We don't need this thing. So 2 will cancel out. So basically, x dx by root of x square plus y square is equal to dr. So I can rewrite my function as dv is equals to k by 4 pi epsilon naught dr. So when I integrate, I get the total potential at distance y from the rod. So that will be equal to k by 4 pi epsilon naught r. Okay. On integrating, I get r. But what are the limits? So we are starting the rod from this point and going all the way up to this point. So over here, the value of r is equal to y. So the lower limit will be y. Okay. What about the upper limit? This is the final length of the value of r for this point. So this is y and this is the length of the rod, 1 meter. Okay, length of the rod is L equal to 1 meter. So this is L. So the upper limit will be root of L square plus y square. So here I need to put the limits y to root of L square plus y square. Okay. So my potential will be Vy equal to k by 4 pi epsilon naught root of L square plus y square minus y. Okay. So this is my potential. And putting the value, or we'll put the values later on. Or let's do that. So this is equal to 1 by 4 pi epsilon naught will be 9 into 10 power 9. Value of k is given to be 10 power minus 9. Okay, k is 10 power minus 9 and root of L is 1, so 1 plus y square minus y. So we get Vy is equal to 9 times root of 1 plus y square minus y. Okay, so this is the potential. Now we put the two values of y. We have to find the potential at this point and this point. So for y1 equal to root of 0.44, v1 will be 9 times root of 1 plus 0.44 minus root of 0.44. Okay. So this will be equal to 9 times root of 1.44 will be 1.2 minus root 0.44. Okay. Similarly for y2 is equal to 1. Okay. v2 will be 9 times root of 1 plus y square, that is 1 plus 1 square minus 1. So this is equal to 9 times root 2 minus 1. Okay. So we found the values. Okay. So delta v change in potential will be v2 minus v1, that is equal to 9 times root 2 minus 1 minus 1.2 minus zero point 0.4 root 44, 1.2 minus root 0.44. Okay, so this is equal to 9 times root 2 plus 1.2 minus 1, root 2 plus 1.2, 1.2 minus 1 is plus 0.2 minus root plus root 0.44. Okay, uh, sorry, this will be minus sign, uh, minus 2.2. Okay, so this will be equal to minus 1.1 volt. Okay, so now they're asking in the question what is the work done in moving the charge from this point to this point. So work done is q delta v. Q is going to be 100,000 microcoulomb. Okay, so work done will be q delta v. So q is 1000 microcoulomb. Okay, into minus 1.1 volt. So this will be minus 1100 microjoules. Okay, so this is the final answer.